Hello and welcome. My name is Dr. Soumya Chaturvedi and I'm here again with the second lecture of the series on the video of computer programming for problem solving using C. In this video tutorial, we will be continuing the topics which we have already done in lecture 1, and then we'll learn some more topics in arrays. So let's begin. First of all, let's do some recapitulations that what we have done in our previous lecture. So in the lecture series on arrays, lecture number 1, we have completed the objectives. First, what is an array? So I'm sure up till now, by watching that video, you must be aware of that what is an array, what are the properties associated with array data structure, what are the conditions with the array data structure. Then further, we had a discussion on why we need an array in C programming. So what is the need of the array data structure in C programming? So we have already done that part with the example set. Then later on, we have completed how to declare an array in C. So we have done some kind of example set as well as programming, hands-on programming example on that topic. Now further, we understood that how we can access certain element of an array using the index values or indices. Then later on, in the last, we have done how to initialize an array. Once the array is declared, then how we can initialize the values or the actual data elements in the array. So in today's class, we will be continuing from this last topic of initialization of array and its type. So let's begin with. Here is the objective of today's class. That is, first we will be understanding the differentiation between compile time array initialization and runtime array initialization. Okay, because in the previous lecture we have done the array initialization part, but there is a slight difference when you have a compile time array initialization and when you have a runtime array initialization. Okay, so we'll be understanding this differentiation with the help of example set. Further, we'll be completing the advantages of an array and some disadvantages associated with array. And definitely when we use something, some technology, it comes with pros and cons. So when we have made in account the advantages part, we have to also look carefully for the disadvantages part, and then we have to logically choose that at what time and in what scenarios we have to use this particular data structure, or in what cases or in what scenarios we should avoid using this data structure. Then further, last objective is access element out of its bound. So that's a kind of logical question that we are going to answer, that what will happen in such scenario. So it will help you to understand the concept better. So let's begin with the first objective of today's video series, that is compile time array initialization. Now compile time array initialization is exactly same as the ordinary variable initialization. So the general form we have already done in previous lecture with the normal syntax, when we have already declared the array, and then with the declaration itself we want to initialize the array. Okay, so the general syntax is you first define the data type, then you have the array name, and then in the square braces you will have the size. So this is the declaration part. Once you write assignment operator which is equal to sign in front of that, and then you have list of values, then those list of values will be kept in each element portion of the array. As you can see in the examples below, we have written integer marks And integer is int is the short form for integer marks, and this marks is the name of my array. And in the square braces I have written 4. That means this array has size 4. That means it has a capacity to hold 4 elements. Okay, now we have after the assignment operator in the curly braces we have written 4 values of integer type like 67, 87, 56 and 77. So this is integer array initialization. Okay, because we have initialized the array with integer values. Okay, the list of values contain integer values here. Now you can notice that we have defined the size, we have declared the size of the array as 4, and we have a list of values. We have 4 number of values. That means 4 elements. In the later example, you can see where we have declared the data type as float and the array name is area, and in the square braces we have defined size 5. That means the array can hold 5 number of elements. When I say can hold, that means this is the maximum element that it can hold. But in case of array, it is not compulsory that if you have defined the size as 5, then you can keep only 5 elements. Though you cannot have more than 5 elements, but you can have less than 5 elements. Okay, so this 5 is the, you can say that this 5 is the at most capacity. That further after 5 elements you cannot add any elements into it. But as you can see in the example, we have only kept 3 values, 23.4, 6.8 and 5.5. Meaning that once we have declared the size as 5 and we are initializing with only 3 values, so what is present in the rest 2 blocks? You try to imagine that pictorial diagram which I actually made you learn in the first video series, that whenever we talk about array, a picture should come into your mind, and that picture is having a contiguous blocks and each blocks can hold 1 element. So in this scenario, in this float area array, when we have defined size 5, so in the memory there will be 5 such blocks, they will be allocated. But because we are initializing with 3 values, so in first 3 index values, at first position, second and third position, we will be having the values consecutively 23.4, 6.8, 5.5, and then later in the 2 blocks for which we are not initializing anything, the values will be 0 and 0. So when you try to imagine it, this will be exactly same as the array of 5 size, in which we have 3 values which are initialized by us and 2 default values as 0 because we haven't initialized value for those 2 indexes. Now let us take another example. As you can see, the third example, integer marks, and again the capacity or the size of the array is 4. And now you can see here, after assignment operator in the curly braces, in list of values we have written 5 values, 67, 87, 56, 77 and 59. Now this situation will generate a compile time error because we have defined the size of the array as 4. That means the array can hold at most 4 elements, but at the time of initialization we are providing 5 values, and this array is not capable of holding 5 values. So the important thing to remember is that when you will give more initializer, When I say initializer, that means array elements by which we are initializing the array. Then the declared array size, then compiler will give an error because we have not allocated the space for 5 elements. We have only reserved the space for 4 elements. Now 5 elements came into picture and the array cannot hold that. So please avoid this. We can have exactly same number of elements which we have defined as in the size. First example. Second example, we can declare the size more, but we can initialize with lesser number of elements, that is permissible. But the third scenario, that you initialize the array with certain size, and if you try to put, or if you try to store the values more than the size, then the compiler will give you error. Let's move on to some example to understand this, that in a C program, how would you say that this is my compile time array initialization? So this is the simple code. Again, a header file is included, and then in the main function, we have initialized one integer variable I, and we have one integer data type array with the name ARR. And in the square braces, as you can see, we have not written any fixed size, but we are defining the size to the compiler by initializing the values. So here we have initialized with list of values containing 3 elements, that is 2, 3, 4. So in the comment also I have written that this is the compile time array initialization part. Now you can see that if I ask one question to you, that in this scenario, in this example, what is the size of my array? Because we have not defined the value of size in the square braces as per the syntax. So the answer is that in this case, because we are initializing it with 3 elements or 3 values, that means the size of the array is now 3 as per the compiler. So this is compile time array initialization, and further in this program what we have done, through the loop we try to access all index values and try to print. So we started from in the array index I from 0 to less than 3. I think you must be aware up till now that the index in array starts at 0 and the index for the last element is n-1 if we have the size n. So in this case we have the size 3, the array is of size 3, then the index will start from 0 to 2, 0, 1 and 2. So what I suggest that while watching this video, you should take a pause over here and note down this example and try to type by yourself in either in online compiler, or if Turbo C is installed in your system, then you please type this code and try to execute the same code, because there is only one way to understand programming languages, by practicing it. If you will just see the code theoretically and do not type by yourself or do not practice by writing the code, then you won't understand. Now what I believe, that if in the same example, if you try to put 5 elements, if you try to initialize with 5 elements, the size of the array will become 5. But if you do not change the range in the for loop, let's say the same example, I suggest that you initialize with 5 values like 2, 3, 4, 5, 6, and then you only print in the for loop, you only go from the value from the index 0 to less than 3. Then you will see that though your array holds 5 elements, but you are accessing through the index value only initial three elements from the starting. So you'll get as an output this. So it is very much required that in case of programming, you try to change the code. You try to alter the code which is already given for you. The first rule is, first you execute exactly same code which is provided in the example, and then try to make certain changes into it and have your own observation that if I change it to that, what is happening, what change I can see in my output. And if by mistake, see, theoretically you can understand, but when it comes to typing, you need to look carefully for statement terminator, you need to look carefully for the braces part, you need to look for the structure of for loop. So this practice is also needed. I think that's enough in a compile time array initialization. Now let's move on to the next topic, which is runtime array initialization. So an array can also be initialized at runtime using scanf function. If you remember, in the lecture 1 series, we have already done one example in which we were using scanf function. If you have any confusion, you can again go back and see in that lecture 1 series that how we have used that function. So this approach is usually used for initializing large arrays or to initialize arrays with user specified values. Meaning that if you can go back into the previous slide, as you can see here, we have initialized with 3 elements or 3 list of values. We can initialize 5, we can initialize 10. But what if we have 100 or 1000 such values, right? So in those type of scenarios, when we have large arrays, or suppose we do not know that what would be my value at compile time. The values will be provided by the user in runtime. In that scenario, you can only declare the size of array, and using the indices part, you can scan one by one the values in the array and can initialize. So example is, that means you have to use scanf function, and then you will put the address of array with the index value, that at which index you want to store which item. So randomly you can access the items or elements of the array using index values. It may be possible that first value you can assign to third location depending on the index value. This is runtime array initialization. Let us see one example to understand it better. In this example, what we are doing, we have defined the array with name ARR and the size is 4. And we have 2 more variables I and j that we are going to use later on. Now, as I said, that runtime array initialization is generally done when we have a very large array, or we do not know at compile time that what will be the value of elements. That means we are going to store or hold some user input value. User will enter the value of array elements. So in this case, we have the size 4. And with the help of printf statement, we have written enter array elements. Now, the general scenario is when I have an array of size 4, I'm expecting 4 values to be stored in the array. So my for loop, which is going to take or scan the elements one by one, it should go from the range of index value from 0 to n minus 1. N minus 1 is 4 minus 1, that is 3. So we will be going in for loop from 0 to less than 4. That means 0, 1, 2 and 3. And each time with the for loop, what we are doing, we are with the standard input function scanf, we are getting the value from the user and then we are storing at the address of, we have written ampersand ARR and in the square braces I, address of the index. That means address of array with the index I. Once we have completed this process, that means when 4 times this for loop will work, all the values entered by the user are now stored in the array. Second, we have another for loop in which we have used another integer variable j, that is for the purpose of printing out the value which is present as an element in the array. So first this program has two parts. First we have taken the input from the user, stored in the array, and then later on we have printed the values. Now what I suggest, you pause the screen over here, you note down this program and try to run it first exactly same code and then try to modify the size of the array and then elements of the array. As I said that if the size is 4 and if you try to put or scan more number of elements, like here in the for loop is less than 4, if you put here less than 5 and try to scan 5 values and enter 5 values by the user, then what error you see? Because generally it is a error that you cannot have that much elements because the array is having a size fixed 4. So at most 4 elements can be stored over there. So this is the way to learn the programming part, that once you run the exact example and successfully, then you try to change a little bit thing as instructed in the video itself and try to observe by yourself with your experimentation that what changes you have observed when you have changed this value to that. That's all in compile time and runtime array initialization. I hope it is clear to you up till now that the array initialization can be done in two varieties. First, either at compiler time or second at the runtime. Let's move forward to some important concepts of advantages and disadvantages of arrays in C. So, starting with the advantages of an array, first important advantage is that random access of elements using array index is possible in case of array. That means if you want to access the fourth element, then you have to only use the index value and you can simply get directly the fourth element. Okay, so this is called random access. You need not to follow any kind of sequence to reach to the fourth element. The second advantage associated with array is use of less line of codes as it creates single array of multiple elements. Remember the scenario, the situation where we have discussed about the need of array. That if you have 100 integer variables and if you try to write that as a simple variable initialization or declaration, you need to write 100 such line of codes. And then you need to do 100 times the scanf statement or to get the value or input from the user for those variables. So array gives you one advantage that you will write less line of codes and you can simply write a single array of multiple elements of same data type. The third advantage is easy access to all the elements. Now, because you have index values, because you have the continuous or contiguous arrangement of elements, that it is very easy to access all the elements from the starting to the last element. Again, The advantage is traversal through the array becomes easy using a single loop. As you have seen in the previous example itself, that with one for loop we traverse the whole array by element by element. At a time, one element we are accessing, and we traverse using only a single loop. So it is very easy. Either it is having 5 elements or 5000 elements in your array, that will be an easy part. The last advantage is sorting becomes easy as it can be accomplished by writing less line of code. Now, the meaning of this line is that because we have a sequence, we have a contiguous allocation, and there is indexes which are associated with each element, it is very easy to sort the elements in the array. Okay, and all the process, if you want to, for sorting also, you need to traverse the whole array, and the traversal is very easy with the use of single loop. So using a loop, you can easily sort in array. Definitely in the later lecture series, we will be understanding sorting and searching features of array with the example. But as of now, you understand that this is also one of the advantage of array. Now we have completed the part of pros. Now we have to go for cons as well. That means disadvantages of array. So the first and very basic disadvantage of array is that it allows a fixed number of elements to be entered, which is decided at the time of declaration in C. As you know, in the previous lecture also I introduced you that the size and data type of array cannot be changed once declared. So if you have already declared the array, so the data type as well as the size cannot be altered. So it allows only fixed numbers. Whatever be the size, at most that much elements can be entered in the array, and further more number of elements cannot be entered, or we cannot alter the size. The second disadvantage is insertion and deletion of elements can be costly, since the elements are needed to be managed in accordance with the new memory location or allocation. Now, the scenario which I am trying to impose you here is that consider the in your pictorial memory, consider that we have 4 elements in my array. Now when I say 4 elements, I am not saying that this is the size of my array. Suppose we have size of array as 6 and we have initialized with only 4 elements. Okay, element number 1, first element, second, third and fourth. Easy. So the rest 2 will be, as of now elements are blank, and we said if this is any integer type of variables we are talking here, that means we will initialize with value 0, 0. Now if suppose you want to insert one element, and my code wishes or my idea is that I want to insert at second position, that I want to have new second element, then in case of arrays, because the arrangement is, memory arrangement is contiguous allocation, so we need to generate a gap in between to insert one element into it. Once we insert one element between 2 existing elements, then we need to have shifts in the index as well as in the memory locations. What will happen? My first element will become my first element is again first, my second element is new, then my second element will become my third element of the array. So as I am suggesting this part, the meaning is when you have those type of shiftings in case of insertions, this is a costly process, because rest all elements are now going to shift. Okay, second becoming third, third becoming fourth, fourth becoming fifth. Likewise, if we try to delete some element in between, let's say in my example set I have 4 elements, first, second, third, fourth, and I wish to delete element 3. Then what will happen? Now my element 4 will become element 3, as there could not be any gaps in case of array. It should be a contiguous arrangement. So this type of adjustment of memory allocation, that means the shiftings in case of insertion or deletion of element, these are costly. I understand that as of now you didn't understood very well about the insertion and deletion process in array. We will be having a separate video series in which we will be talking about the insertion of element in an array, deletion of element in an array, and with the example set in that video I will be showing that to you in detail. But as of now you can understand the terminology that insertion and deletion operation are costly in array, whereas the traversal or the sorting part or the searching part, that is pretty easy in case of array. Let us move onwards to the last topic of today's video series, that is access elements out of its bound. In previous case we have seen that when you have the size of array as 4, you can declare 4 elements or lesser number of elements. When you try to declare more number than 4, the compiler will give you the error that the capacity of array is only 4, you cannot initialize more than 4 values. Now suppose you declared an array of 10 elements. Let's say I have written in the slide for you, it is integer, this is my test array and the size is 10. That means this array can hold maximum 10 number of elements. Now if I try to access these elements, you can access the array elements from index 0 to 9. We have 10 elements, so from 0 to 9 that will be the indexing. So from test array 0 to test array 9 we can traverse the whole array. Now let's say if you try to access test array with the index value 12. Now remember that in your pictorial memory, if you can try to imagine that when we set 10 elements, that means there will be 10 blocks, consecutive blocks. Indexing is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8 and then 9. At 9 it will end. And we are trying to access the index 12. This 12 is not existing anywhere. So the element is not available because we are talking about accessing the element at this location. This location does not exist, then the element is not available. Now this may cause unexpected output. When we say unexpected, that means undefined behavior. We are not aware of that what will happen in this scenario. Now sometimes you might get an error, sometimes the program may run correctly, or maybe you will get certain garbage value or whatever. But this is known as out of bound situation. Okay, so hence you should never access elements of an array outside of its bound, because if you are using the whatever you are accessing and whatever output you are getting from this access of elements, if you are using it into next in your program in some logic, that will definitely unpredictable. Sometimes you'll get something else or sometimes you'll get something else, because this is going to show you undefined behavior, which is not good for programming perspective. So you should never access elements of an array outside of its bound. In programming or in case of vivas or interviews, you could be asked with this question: do you have any idea of elements out of bound situation? How you will say that this is out of bound? So you can explain this example that when we have a definite size, then we can have indexing only in that size, like we have 10 elements, then the indexing can range from 0 to 9. And if we try to access index 12, then it is not existing, so we will have unexpected output, and this is not good situation, and this is known as array out of its bound. So here is the summary. Let's have a quick summarization of what we have done. First is uninitialized array always contain a garbage values. This is what the thing which I want to say, and I want you to check this also, that in your C program you only declare one array, do not initialize any value, and try to access with the help of index value, try to access the elements and try to print the value. So you'll see some garbage values will be printed. Okay, so uninitialized array always contains garbage values. Second, if you will give more initializer or array elements than the declared array size, then the compiler will give an error. Then you cannot initialize more number of elements than your defined size. The third point is we have done with the advantages part, that is traversal and sorting is easy in case of array, but in disadvantages we have seen that insertion and deletion of elements can be costly. So this is also very important point, and we have covered that. And the last is you should never access elements of an array outside of its bound. So this is the situation of out of bound array. So here is the summary. I hope the objective, after watching the video series, the objective is achieved. You are now aware of the differentiation between compile time and runtime array initialization. What are the various advantages and disadvantages associated with array, and what is the scenario of array out of bound situation. So again, here is this references. You can see, you can have these books as a reference, and this is my contact information. In case you want to have a discussion or you feel that you need some more clarification on the topic, you can email me. I will be happy to answer. Till then, keep learning. Thank you for watching.